Hey YouTube, welcome back. Today we continue our series in design key value store. We have a series that we solving system design interview question, which is design a key value store. In the previous video, we talked about how to understand the problem and how to propose a high level design. In today's video, we'll talk about the important topic which we will face in basically every system design interview, which is the CAP theorem. So let's just talk about what is a CAP theorem. So CAP theorem. Okay. That sounds good. And let's just add it on here, and let's just make it quite small one. Yeah. And let's just make it with the white. So the CAP theorem, it's talk about three things mainly. First is the consistency. Second is availability. Third is the partition tolerance. Availability. What this means? The consistency means all clients see the same data at the same time, no matter which node they are connected to. Availability means any client which requests data gets response even if some of the nodes are down. The partition tolerance means that a partition indicates a communication break between two nodes. Partition tolerance means the system continues to operate despite network's partitions. The CAP theorem states it is impossible for any distributed system to simultaneously provide more than two of these three guarantees: consistency, availability, and the partition tolerance. So it will look like something like, let's have oh no, what is this? Delete please. Let's copy it. So it will be something like that. No, it will be something like yeah. So basically, let's say this one will be the consistency. Let's make it smaller so it will be easier for us to see. Let's delete it. Delete this one, and let's just add text. So basically, let's say this is consistency. Oh, this is very big. This is consistency. What happened? What? Miro, you annoys me, Miro. You annoys me so much. We have the consistency, and let's just make it small, and let's just put here, and we have the consistency, and let's just give it green color, and we have this. Oh no, please, no, please. You're like Sorry, I'm pretty pissed off easily. I had a availability. I had a really tough day at work today. Availability. Availability. It's not X, it should be Y. And let's just have it with this color. Okay. And let's just make it smaller. I guess it will be better to be smaller. And yeah, make it smaller. And then we have the partition tolerance. Let's just make it PT. I'm not focusing at all. Partition tolerance. Okay. Let's give it the red one. So basically, we have these three subjects or objects: the consistency, availability, and partition tolerance. And we can't provide the three of them. We can provide a consistency and a partition tolerance. So it will be like a CB system. Yeah, CB system. So let's just put over here both of them. So we have here a CB system. CB system, and we could have a partition tolerance and availability, which will be AB system, and we could have a consistency and availability while sacrificing the partition tolerance. So it will be AC system or CA system. So basically here, in this system, let's say that we have this system, so the CP system, we guarantee that to have the consistency and the partition tolerance, but we're sacrificing the availability. In the AP system, we guarantee to have the availability and the partition tolerance, but we're sacrificing the consistency. And in CA system, we in the consistency and availability system, the CEK value store will support consistency and availability while sacrificing the partition tolerance. And since network failure is something that we cannot avoid, a distributed system must tolerate network partition. Thus, a CE system cannot exist in a real-world application. So basically, the CE system is not something that we can depend on, because it's not something that live in a real-world application, because we cannot avoid partition tolerance. We cannot avoid it. So again, CP system is that a key value store supports consistency and the partition tolerance while sacrificing the availability. The AB system, because we are designing a key value store, so I'm talking about key value store. So AB system, it's the key value store supports the availability and the partition tolerance while sacrificing the consistency. And the CE system, as we said before, the key value store supports the consistency and the availability while sacrificing the partition tolerance. Since the network failure is something that we cannot avoid, a distributed system must tolerate network partition. Thus, a CE system cannot exist in a real-world application. So, from what we have described, it is mostly the definition part. To make it easier to understand, let us look at some like concrete example. In distributed systems, data is usually replicated multiple times. So let's assume that data are replicated across 3 replicas. Let's assume that we have 3 replicas. Let's say that we have like N1, and can I copy this one? Yeah, thank you. And we have N2. Let's just make it here. Yup. Okay. We have N2 and N3, and all of them are communicating with each other. I want to make this one white. and I wanna can I make it with like I don't want to have any arrows. I don't know. Let's just have it like that, and these replication are connected with each others. And just can we have this on here? Because I guess it will be quite, yeah, it's reasonable looking like that. So basically, in ideal world, network partition never occurs. So data written to N1 is automatically replicated to N2 and N3. In a real world distributed system, in distributed system, partition tolerance can be avoided. So, and when a partition occurs, we must choose between consistency and availability. So, in as you can see here, let's say let's just have the pen because I guess we'll use the pen. So basically, as you can see here, so when N3 goes off, okay, when N3 goes off and cannot communicate with N1 and N2, if clients write data to N1 or N2, data cannot be propagated to N3. And if data is written to N3 but not propagated to N1 and N2 yet, N1 and N2 would have a stale data. So let's just try to think about that. So let's say that maybe N3 has fall, or maybe the partition tolerance has fall between the connection in with N3 and N1 and N3 and N2, and we have new data has been written to N1 and N2, and maybe this data will not be published to N3 yet because the partition there is a partition occurred, and if someone write data to N3, it will not be appeared in N3 and N1 and N2 because there is no connection between them. So we could go to have a still data. So if we choose consistency over availability, let's say that we are choosing the consistency over availability, we must block or write operations to N1 and N2. So basically, if N3 partition tolerance, if NG cannot connect with N1 and N2, we cannot accept any write requests to N1 and N2 at all. And to avoid data inconsistency among these servers. So we do this to avoid data consistency, which makes the system unavailable. For example, bank system usually have extreme high consistency requirements. For example, it is crucial for a bank system to display the most up-to-date balance info. If inconsistency occurs due to a network partition, the bank system returns an error before the inconsistency is resolved. However, if we choose the availability over the consistency, which is the AP system, the system keeps accepting reads even though it might return stale data for even though it might return stale data. So for writes N1 and N2 will keep accepting writes, okay, and data will be synced to N3 when network partitions is resolved. So the choosing the right cap guarantees that fits your use case. It's important, and in this system, because we are highly available, we prefer to have available system. We will go with the AP system, and we will talk about how we can solve this consistency problem, and it will take from us a lot of videos to talk about that. So yeah, let's just go back. So yeah, that's it for today's video, and I hope my description is quite good. If you like my content, make sure to subscribe and hit the notification bell so you will never miss any video, hopefully. And yeah, see you guys in future problems.